All right, I've heard from several of you that you really are enjoying this College Board activity, so thought I'd enjoy it myself. I know some of these questions are a little bit involved, trickier than some that we've done recently, but I think if we just slow down and work through these a little bit, I think we'll be okay. We'll realize it's really not that bad. Now, that being said, they are tricky questions. They are challenging. So if you're having a hard time with them, don't worry. These are challenging questions. But I think if we work through them slowly together, we can see that we can do this. All right. First bit of advice. Let's just read what they're asking us for. Find f double prime of e to the 1.5. Well, if I need f double prime and I need to plug in e of 1.5, usually that tells me I need to take the derivative of some function and then take the derivative of that. So that's what they're asking me. Now I look at what are they giving me. Well, they've given me this table of values for a differentiable and decreasing function g and its derivative. And then they told me let f be the function with f of 1 equals 0, and then this is the derivative. So now I combine those. Okay, I need f double prime, and look at what they gave me. Hey, they gave me f prime. A couple people that I've talked to have said, well, how am I supposed to find f double prime if I don't have f? Well, you don't need f because you already have f prime. So just take the derivative of f prime. Doesn't matter what f was at this point. Maybe later we'll need it, but right now we don't. So as I look at this derivative, or this function, I need to take the derivative of it. First thing I ask, well, what rules do I need? I need product rule because it is x times sine of x squared. And then because it's not just sine of x, it's sine of x squared, I need chain rule. So when I think about my product rule, I like to think about that as, okay, I need the derivative of, I'm not going to use f and g because it's already in this problem. I'm going to say I need the derivative of p of x times q of x. And I know that the product rule says that equals p of x times q prime of x plus q of x times p prime of x. So now I just need to stop and think, okay, well, in my problem, what's p and what's q? Well, it's x times sine of x squared. So x I'm going to call p of x equals x, and thus p prime equals 1. That's friendly. And then q of x equals sine of x squared. Nothing wrong with breaking the problem down, showing a bunch of work, making each chunk a little more manageable for yourself. And so in this one, I need chain rule. So then I need to break that down and say, well, u equals x squared. And q equals sine of u. So then du dx is equal to 2x. dq du is equal to cosine of u. Multiply that together and plug back in for u, and that will give me q prime of x. So that's going to be 2x times cosine of u, where cosine of u is really cosine of x squared, because u is equal to x squared. So all that is just q prime. And so what I have here, I have the pieces for my product rule. P of x, q prime, q prime, q of x, p prime, p prime. So I just need to put those together into my product rule there. Let's shift this up just a little bit so that I can write it all out. So my derivative here, my f double prime, and this whole derivative, all is a product rule. F double prime of x is equal to p of x, which is x, times q prime, which we just figured out, is 2x cosine of x squared, plus q of x, which is sine of x squared, times p prime, which is just 1, which of course I don't need to write, but I will write it anyway just to show it. Now the question doesn't stop there, but I'm going to leave you there because the question says find f double prime of e to the 1.5. So I just need to plug in e to the 1.5. Now why did they give you such an ugly number to plug in? I don't know, but it doesn't matter. Don't let an ugly number freak you out. It's just the same as if they had asked you to plug in 3. Just plug it in everywhere you see an x. And the directions say express your answer as a decimal. So they want you to plug this into your calculator with the e to the 1.5 and write that decimal there. That's part A. Pause, write it down. I got to get rid of it because I need more room for part B. All right, part B. Now they give us a new function, h, and they want h prime of 0. Well, same deal. Okay, how am I going to find h prime? Well, what is h? Well, h is this gnarly thing here. And that's a 3-part chain rule. 3 of x inside g inside f. So I need to break that down in terms of chain rule. Inside part first, u is equal to 3x. V is equal to g of u, and h is equal to f of v. Each of those derivatives, I'm just going to call it u prime this time, be a little lazy, is equal to 3. V prime is, well, now I'm confused because I don't have an equation for g. So how am I supposed to take the derivative of g if I don't have the equation for it? Well, I got to think forward. What are they really asking me for? They're asking me for h prime of 0. So it doesn't actually matter what the derivative is as long as I'm able to plug 0 into it. And so that's where I look at my table. I say, you know what? I don't have a formula that I can write down for g or g prime, but I do have a table, and I can maybe plug in 0 or a few other numbers to that. So let's just let it ride for a second and say, I don't know what the derivative of g is, but I know a couple values, so I'm just going to call it g prime of u. Same down here. H prime is just equal to f prime of v, because I don't have a derivative for, or I don't have an equation for f. How am I supposed to take the derivative of it? But wait, this time it's even better because not only did they give me a table of values, but they actually just gave me f prime. So that's super friendly. So many of us were freaking out, like, how am I supposed to take this derivative? Well, you don't need to. They already took the derivative for you. We stop, we slow down. What are they asking me for? What did they give me? How can I bridge that gap from what they gave me to what they asked about? What are the small little chunks, small pieces that I can actually do? And then usually we will find, oh hey, I can do this. Just need to break it down. So because it's chain rule, we have to multiply it all out. H prime of x is equal to each of my derivatives multiplied together. So 3 times g prime of u times f prime of v. Gotta substitute back in for u and v. So it's 3 times g prime of 3x is u. And then instead of f prime of v, that's really f prime of, well, v is g of u, so that's really f prime of g of 3x. And now I want h prime of 0. So that's 3 times g prime of 0, because 0 times 3 is still just 0, times, missed a parenthesis there, sorry, f prime of g of 0. look at my table. What's g prime of 0? It is, plug in 0, g prime is negative 7. Negative 7. F prime of g of 0. Well, g of 0 is 4. So what's f prime of 4? Well, I don't have a table of values for that, but I do have a function. So I can just plug in 4 to this guy and put that there, and then multiply it all out, because they want it rounded as a decimal. Okay? I'll leave you to do that little bit of calculator arithmetic there. Okay, moving on to part C. Let's get rid of this. Pause, write it down. Rewind. If I do it too quickly, you can just go back and magically see it again. All right, part C. Write an equation line for the line tangent to the graph of g inverse, the inverse function of g at x equals 1. So today in class we looked at inverse or derivatives of the inverse. And the derivative of the inverse we can do two ways. If they give me an equation for the original, I can simply swap the x's and the y's and take the derivative using implicit differentiation. If they don't give me the equation, then I have to use the rule from class, which was that the derivative of the inverse, we used f in class, but this one is g. The derivative of the inverse of g at b is equal to the reciprocal of the derivative of the original at a. Now what are a and b? Remember, the original function has the point a comma b, input A, output B. The inverse has those two values switched, because that's the definition of an inverse. You switch the input and the output. So what they really are asking about, they're asking for the derivative of g inverse at x equals 1. So putting that in the notation of our formula from class, they're asking me what is the derivative of g inverse of negative 1? Well, to find that, I need to have the reciprocal of the derivative of g, not g inverse, at a. But what is a? Well, I don't know. I know that my input on my inverse is negative 1. So b, again, as we said already, is negative 1. I need a, which is I can think about a as two things. It's the output of the inverse if you input b, or it's the input on the original that spits out b. Because I don't have any real information about g inverse, I've got to think about it in terms of the original, because that's what I have information about. This is an output value. What's the input that gave me negative 1 on the original? Hey, I've got a table of values that can do that for me. Where is g having an output, a b value, of negative 1? Oh, right there. What was the a value, the input that got me there? 2. There we go. So a equals 2. And that needs to go over here. So I then have 1 over the derivative of g at 2, derivative of g at 2, which the table tells me, let's move all this up just a skosh. The table tells me that the derivative of g at 2 is negative 3. Right over there. So this is 1 over negative 3. Done. Okay, part D. Again, pause, write it down, watch it again if you need to. Part D. Okay, they give us a point on the curve, and they want to know the value of dy dx at that point. Well, again, what have they asked me for? They've asked me for a derivative of this curve. Did they give me the equation for it? Yes, they did. Can I take that derivative? Yes, I can. Is it a little bit ugly? Yes, it is. But I can do it. Sum and difference rule says to take the derivative of each term separately. First term, how do I take the derivative of f of x? I don't have an equation for f of x. Well, it's f prime of x. They already gave you f prime of x. Why worry about knowing f of x just to find f prime if they already gave me f prime? Next term, well, this is ugly. It's a chain rule with a function inside of it that I don't actually know. But if I do that chain rule, it's going to be 2 g of x times g prime of x. Now hold on, wait a second. I don't know an equation for either g of x or g prime of x. But wait, think about what they're asking you to do. They're asking you to eventually plug in numbers. And the number that I'm plugging in here is 1. And if I look back at my table again, I do in fact know both g of 1 and g prime of 1. So I can do that. And then on the other side of the equal sign, I've got a nice friendly product rule with implicit differentiation. Leave the first one alone, multiply by the derivative of the second, plus derivative of the first one, leave the second one alone. Again, I don't need to write the 1, I just write it there to make it look like a product rule. So now I need to plug in 1 for x and 4 for y and solve for dy dx. So I need f prime of 1 plus 2 times g of 1 times g prime of 1, set that equal to 1 dy dx plus 4, because y is 4. And then just solve that equation for dy dx. Now you will have to plug 1 into the given function for f prime. Plug 1 in here to get that value. And to get this value, I will need to find g of 1, which is 2, and g prime of 1, which is negative 2 from my table. Then I can simplify it all and just bring the negative 4, or bring the 4 over and get my value for dy dx. It looks ugly, it looks complicated, they didn't tell you all the stuff in the way that you wish they told it to you, but they still told you what you need to know. And so it's just your job to stop and think, what did they tell me here? What did they ask me for? How can I get from what they gave me to what they asked me for? I'm going to go ahead and stop this video, and we'll start fresh for number 2 so that we don't end up having a 40-minute long video here.